In this video, we're going to look at another form of a linear equation in two variables. Thus far, we've talked about this ax plus by equals c, which is called the standard form. And now we're going to look at something called the slope-intercept form. And before we do that, I want to just take this equation that I have on the screen, 3x plus 2y equals 6, and I want us to think about what is the slope of this line, what does the graph look like, and what are the intercepts. And so to even find the slope of the line given an equation, you have to know two ordered pairs that lie on the graph of the line. And so we can find two specific points which are intercepts. So let's think about what would be the x-intercept and the y-intercept of this graph. And we've already done this in an earlier video, but we'll do this here real quickly. So the x-intercept, we let y be 0. If y is 0, the 2 times y would be 0. So we just have 3x equals 6, or x is equal to 2. So 2, 0 is the x-intercept. The y-intercept, we let x equal 0. Letting x equal 0, the 3 times 0 is 0, so we're left with just 2y equals 6, or y would be 3 after dividing by 2. Therefore, the y-intercept is 0, 3. We can get the graph if we want by plotting 2, 0, 0, 3, and then when we draw the graph through those 2 points, we see that the graph is a downward sloping line. When we find the slope of this equation, we can use the y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So if we labeled 2, 0 as x1, y1, and 0, 3 as x2, y2, we get 3 minus 0 divided by 0 minus 2. Or 3 over negative 2, which is the same thing as negative 3 halves. So thinking about the rise and run, notice that negative 3 halves can really be the same thing as negative 3 divided by 2. And remember how we talked about the slope indicates some movement between 2 points on a line? If we start at this 0, 3 to get to 2, 0, we would have to go down 1, 2, 3, and right 2. So down 3 and right 2. And that is exactly what our slope indicates, that movement. A negative in the numerator indicates that it's going to rise downward, and the positive 2 means we're going to run to the right. Now actually this 3 divided by negative 2 means I could go up 3 units and left 2 to get to another point on the graph of the line. Any equivalent form of that fraction will give us the same slope. Now here's another connection I want us to make. So to find the slope, we found 2 points and plugged into the slope formula. But what if there's an easier way? What if it's actually staring at you in the equation? And so let's look at what happens if I solve the 3x plus 2y equals 6. Let's solve it for y. And so if we solve this equation for y, we would have to subtract the 3x, so we get 2y equals negative 3x plus 6, and then we divide by 2. When we divide by 2, we get y is equal to negative 3 halves x plus 3. And lo and behold, what do I see? The slope is this coefficient of x, negative 3 divided by 2. Now what is the value of 3? Well, 3 was our coordinate, y-coordinate of our y-intercept. And so this y equals negative 3 halves x plus 3 is actually what we will call the slope-intercept form of a line. So solving an equation that's in standard form or some other form of a linear equation in two variables for y, the coefficient of x will be the slope. And remember, slope stands for the numerical steepness of the line. It also tells us the direction the line goes in based on its sign. Now here's a really cool other fact about this. I took some screenshots from the graphing calculator. I started with this 3x plus 2y equals 6, and I entered into the equation editor the equation that we just found. Y is equal to negative 3 halves x plus 3. I graphed it on the right so you can see that graph that we just obtained by hand. But then I have a table of values. And remember, to get the table, I can press second and graph on the calculator. And this table of values gives me some x values and y values that are ordered pairs. That is, they're solutions of this equation. But what I want you to understand is what happens as I go through the table to consecutive x values and what happens to the y value. And so whenever I do this, as I go from -6 to -5, I've increased my x value by 1. And from 12 to 10.5, I've decreased by 1.5. From -5 to -4, that's an increase of 1. From 10.5 to 9, it's a decrease of 1.5. -4 to -3, increase of 1. From 9 to 7.5, a decrease of 1.5. -3 to -2 plus 1. 7.5 to 6, decrease of 1.5. And I can continue that through every row in my table. As long as I have this consecutive unit change in x, I see that my y values are decreasing by 1.5. Well, how does that play a role? Remember, this is change in y divided by change in x is my slope. So according to this, my change in y is a -1.5 and my change in x is a 1. So I get a -1.5. Well, remember the -3/2 was my coefficient of x, or my slope that I found through the intercepts. But what is -3/2? As a decimal, it is -1.5. Now, another interesting thing I can see, what happens if I change, like, see this change, decrease of 3 for every 2 unit increase in x, right? Change in y over change in x, say -3 over +2. So what happens if I increase my x by 2? So let's go from 0 to 2. It's an increase of 2. And to go from 3 to 0, notice that that decreased by 3. From 2 to 4 is an increase of 2. And from 0 to -3 is a decrease of -3. So like I was saying earlier, as long as the ratio is the same value as the slope, it's going to be constant through that line. So the important part of that discussion is the fact that if you have an equation in the form y equals mx plus b, this is called the slope-intercept form of a line, where m represents the slope of the line and 0b is a y-intercept. Now in function notation, remember y is equal to f of x. It's function notation. So if we have y equals mx plus b, we can write that in function notation, which would then give us a linear function. And so a linear function is defined to be a function of the form f of x equals mx plus b. So a linear function is defined by f of x equals mx plus b. The graph of a linear function is an oblique or slanted line as long as m does not equal 0. A constant function is defined by the function f of x equals b, and the graph of a constant function is a horizontal line. So this is a case where the value of m is equal to 0. And remember, y equals a number is the graph of a horizontal line. Now the domain of linear and constant functions is a set of all real numbers, which is -infinity to infinity. There are no restrictions on what we can input into that function. The range of a linear function for m not equal to 0 is -infinity to infinity. If you recall, if we have a line that's slanted, like if I have a line that goes from the third quadrant through the origin and up into the first quadrant, the highest and lowest point goes from -infinity to infinity, right, for the range. And so the range of a linear function that is not a horizontal line is all real numbers. If it is a constant function, The graph of that is just a horizontal line, and there's only one y value that's on the horizontal line. So in that case, it's whatever the y value is of that line. Now, in this example, we will write the equations that were given in slope-intercept form, and then we want to write them using function notation if that's possible. Then we'll use the slope and the y-intercept to graph, state the domain and range of the function, and whether the graph is increasing, decreasing, or constant. Here we have this equation 2x minus 4y equals 8. To write it in slope-intercept form is just code for solving the equation for y. That is, write it as y equals mx plus b. To do this, we first have to subtract 2x to get negative 4y equals negative 2x plus 8. Then, to solve for y, we divide each side, which is the equivalent of dividing each term, by negative 4. We get y is equal to negative 2 divided by negative 4. When we reduce that fraction, we get a positive 1/2 x. 8 divided by negative 4 is negative 2. In function notation, this equation is equivalent to f of x is equal to 1/2 x minus 2. The slope of that line is the coefficient of x, which is 1/2. And then the y-intercept is 0, negative 2. And remember, if you need help finding the y-intercept, you replace x with 0, and you get 1/2 times 0 is 0 minus 2. So that is why it's always this constant number that is in the equation. Now, how can we use that information to graph? And we'll answer the domain and range in just a minute. So we think about the slope is how we move from one point on a line to another point, right? It depicts the rise and run between points. The y-intercept is a specific point on the line. So think about B is telling you where to begin, and M is going to tell you how to move to another point. We will begin at 0, negative 2, and then we'll move according to our slope. Our slope is 1/2, which is rise divided by run. This means for us to rise from that beginning point of 0, negative 2, we rise 1 unit and run 2. So that will take us up 1 over 2 to the point 2, negative 1. We can repeat that process if we want to. Go up 1, right 2 takes us to 4, 0. And then we can get the graph through that line. Again, using a ruler and paper will make those very precise. Now, what is the domain and range of this function? Well, this is really a polynomial function, kind of the simplest form, 1/2 x minus 2, a linear function. The domain is all real numbers. As we read from left to right, the graph extends in both directions infinitely without any stops or gaps. And the range is a set of y values, which is from bottom to top, but it extends infinitely to the downward direction and upward direction without any stops or gaps. So the range is also negative infinity to infinity. And because our slope is positive, the line is increasing, right, or rising from left to right. So we have an increasing line. Here we have x plus 3y equals 0. We first write it in slope-intercept form, which means solve the equation for y. We do that by subtracting x from each side to get 3y equals negative x. Then divide by 3 to get y is equal to negative 1/3 x. In function notation, this will be f of x equals negative 1/3 x. So the slope of the line is the coefficient of x, negative 1/3, and our y-intercept is this constant term, right, which is 0. So the y value of the y-intercept is 0, which would be 0, 0. To plot this graph, we will begin at the y-intercept of 0, 0. The slope of negative 1/3 tells us we're going to rise by negative 1 and run by 3. That is, we go down 1 unit and right 3 units, which takes us to 3, negative 1. If you want to, you could go up 1 unit and left 3, because that is equivalent to the slope, which is negative 3, 1. So then drawing the graph through those points gives us the graph of the line. The domain, again, it extends infinitely in each direction. It's negative infinity to infinity. The range from bottom to top, it extends infinitely in each direction to get negative infinity to infinity. And is this line increasing, decreasing, or constant? Well, it is going down from left to right, which tells us that the line is decreasing, which we knew that because of the negative slope as well. Now we have the equation y equals 1. It's already solved for y, and we can write this in function notation as f of x equals 1. Recall that there's an implied 0. This is equivalent to 0x plus 1. So the slope of this line is 0. The y-intercept is 0, 1. But also remember what we've learned before. Don't forget that. Y equals a number is the equation of a horizontal line. Y equals a number was also how we defined a constant function. To graph that using the slope and y-intercept, though, we plot or begin at 0, 1. Our slope of 0 suggests that there is 0 rise, and then our run can be whatever we want it to be, because 0 over any number is 0, but we'll think of it as 0 over 1. So if we don't rise anywhere, but we just go right 1. Don't rise, go right 1. So we can see that the points form a horizontal line through 1 on the y-axis. What is the domain? It extends infinitely to the left and to the right, so negative infinity to infinity. The range is just a set of y values, but the only y value that this graph goes through is a y value of 1. So it's just a set containing 1. Because our slope is 0, this line is a constant line, right? It never goes up or down. It stays the same for all values of x. Now we want to look at a different type of problem, but still using the slope-intercept form. We want to write the equation of the line in slope-intercept form that satisfies the given criteria. Then we'll write it in function notation. So we know that our line goes through the point 0, 7 and has slope 4. Well, the information that we are given is actually the exact information that is obtained from the y equals mx plus b form. Right, 0, 7, that is the y-intercept. This tells me, therefore, that the 7 is the value of b. And slope is a coefficient of x. It tells me that m is 4. Therefore, the slope-intercept form that satisfies this criteria is y is equal to 4x plus 7. In function notation, this is just f of x equals 4x plus 7. Part B is the line goes through the point 4, 7 and has slope 3/2. Well, this one's a little bit different, right? I don't know the y-intercept. I know some other point 4, 7, but I do know the slope is 3/2, which tells me m is 3/2. So I need to figure out what is b. How do I find b? I think of the given point as a point x, y that satisfies the equation of the line. So I'm going to write y equals mx plus b. I know an x, y, and an m. If I substitute those values into this equation, I can solve for b. Y is 7. is equal to m is 3/2 times x is 4 plus b. So 7 is equal to, well, 3/2 times 4 is 6 plus b. Subtract 6 from each side, b is equal to 1. Therefore, the equation in slope-intercept form that goes through the point 47 and has slope 3/2 is y is equal to 3/2 x plus 1. In function notation, it is f of x equals 3/2 x plus 1. So actually, I know what the y-intercept of that line would be. It would be 0, 1, now that I know the value of b. In part C, we have a line that has x-intercept of 2, 0, and has slope -3/5. So again, I know an intercept, but it's not the y-intercept, so I don't know the value of b. I can think of 2, 0 as a value of x and y, and my value of m is -3/5. I use y equals mx plus b. We will replace y with 0 from the given point. M is -3/5, and x is 2, and then plus b. So multiplying -3/5 times 2, remember 2 is 2 over 1, so we multiply across to get -6/5 plus b. And to solve for b, I can add 6/5 to each side to get 6/5 is equal to b. So therefore the equation is y is equal to, I know m, which is -3/5 x, plus my value of b, which is 6/5. And in function notation, it will be f of x equals -3/5 x plus 6/5. And then a last example with the slope-intercept form is we can use it to model and give information about how things are changing. This example gives us a population in millions of the United States on January 1st, X years after 2010, can be approximated by the function f of x equals 2.2535x plus 308.51. According to the model, what is the population in 2010, and how is the population changing each year? Since x stands for the years after 2010, to find the population in 2010 means we're trying to find what is the population when x is equal to 0. And if we find f of 0, we get 2.2535 times 0 plus 308.51, which is just 308.51. So the initial population, or the population in 2010, was 308.51 million. Now, I could have obtained that just from looking at the equation because I know that this is in slope-intercept form. So the 308.51 corresponds to the y-intercept of 0, 308.51. So this constant term always represents the initial or base value of the function. Now, how is the population changing each year? The change is designated by our slope. We know that the slope of this function is 2.2535. We need to think of that as a fraction so we can see the rise divided by run. So this is the same thing as 2.2535 divided by 1. And when we think about change in y divided by change in x, let's put that in terms of this problem. The y is representing the population, so this is really the change in the population in millions. And the x is representing the change in the years. Therefore, the population is increasing by about 2.2535 million per year. right? Because this is saying y goes up by this 2.2535 as x goes up by 1.